Hello everyone, welcome to MG Academy. The next topic in data structure is applications of stack. Okay, so the first application of stack is reversing a string. This is one of the most basic application of stack. We know in stack there are two operations, push operation and pop operation. And with the help of these two simple operations, we can reverse a given string. Okay, so now let us take an example. We'll consider a string as MG Academy and okay. So suppose this is a string which is given to us and we have to reverse it. So with the help of stack we can easily reverse it. First we will consider a stack. And now we will push all the characters into this stack one by one. Okay. Suppose we have pushed all the characters in this stack. Now we'll pop the elements from this stack, and we know that the elements are popped from the top, and whichever element which is at the top of the stack will be popped first. So the first element in this stack is y. So y will be popped first, isn't it? Y, first y, after that n, after that then b, then a, c, a, n. So after popping all the elements from the stack, we'll get this string. And this is nothing but the reverse form of this string, isn't it? So with the help of stack, it is very simple to obtain a string in its reverse form, isn't it? So with the help of only push and pop, we will obtain a reverse string. This is the first application of stack. The second application of stack is parsing well-formedness of parentheses. Well-formedness means we will check whether the parentheses are balanced or not. So in any expression, suppose arithmetic expression, isn't it? So in arithmetic expression, we use parentheses. Also, while writing program, we make use of parentheses, isn't it? So for that, we have to check whether the parentheses are balanced or not. That is, whether they are well formed or not. So this can be done with the help of stack. Now, for understanding this, we will consider a random string of parentheses like this. Suppose. So this is a random string of parentheses, and we have to check whether it is balanced or not. So this is very small string. So by looking at this string, we can say that yes, it is balanced. But how to check it with the help of stack? So for that, we will consider a stack, and all the left parentheses will be pushed into the stack. So first, second. So these two are the left parentheses. This parenthesis will be pushed into the stack. Okay. Now both the parentheses are pushed into the stack. Left parenthesis. Now we will wait for the right parenthesis. And whenever we will encounter a right parenthesis, we will pop one left parenthesis from the stack. Okay. Now while passing this string, we came across one left parenthesis. We pushed it. Second, again we pushed it. Now this is a right parenthesis, isn't it? So whenever we encounter a right parenthesis, we will push one left parenthesis from the stack. So one right parenthesis, so one left parenthesis will be popped. So now this is cancelled. Again, when we see a right parenthesis, another left parenthesis will be popped. So now after reading whole string, we can see that the stack is empty. And if the stack is empty, we can say that the given string is a balanced string of parentheses. isn't it? Now let us consider another example in which the string is not balanced. For example, one more string. Now you can see there is one extra right parenthesis, isn't it? Now again we'll create a stack. Now we'll read the string. So first left parenthesis pushed, second left parenthesis pushed. Now the right parenthesis, as we know, when we encounter a right parenthesis, one left parenthesis, recently pushed left parenthesis will be popped from the stack. So this is recently pushed left parenthesis. So this parenthesis will be popped from the stack. Again we'll read, and now another right parenthesis. So again this remaining left parenthesis will be popped from the stack. And now the stack is empty. But there is one more right parenthesis left, isn't it? And there are no parentheses in the stack. The stack is already empty, which means that the string is not balanced. If there was one more left parenthesis, in that case the string was balanced. But now there is one right parenthesis, but there is no left parenthesis to be matched. So we can say that the given string is not balanced and this string is balanced. So with the help of stack, we can check whether the given string of parentheses, the parentheses given in any expression or program are balanced or not. Okay. And the third application is the expression conversion. So as we know, there are three types of expression: infix expression, postfix expression, and prefix expression, isn't it? So there are three types of expression: infix, postfix, and prefix. And there is interconversion here. That infix expression is converted into postfix expression, and again infix expression is converted into prefix expression with the help of stack. So this is one application of stack, and the fourth application of stack is expression evaluation, like evaluation of postfix expression. So evaluation of postfix expression is also done with the help of stack. Okay, so these are the four applications of. And before understanding last two applications, we'll first understand in detail what are infix, prefix, and postfix expressions. Okay. So now let us see what is an expression. So expression is a string of operator and operands. So operator and operand together form an expression. So what are operator? Like operators are plus, minus, multiplication, division, exponent. So these are operators. And what are operands? Alphabets, numbers, these are operands. And this together forms an expression. Okay. Now, based on the arrangement of operator and operands in an expression, there are three types of expression: infix, prefix, and postfix. Now let us see what is an infix expression. So in infix expression, the operator is written in between operands. Operator is written in between the operands. So for infix expression, we can write here as infix expression equals to operand, then operator, and then again operand. This is how an infix expression is formed. Examples are a plus b, or 2 plus 3. 2 plus 3 are operands and plus is an operator. Also 2 plus p. So these are the examples of an infix expression. Now let us evaluate the infix expression. So first 2 plus 3. So After performing 2 plus 3, we'll get 5. Okay. Now, if the expression is little big, for example, 4 plus 6 into 2. Now, in this expression, there are two operators, plus and multiplication, isn't it? So, now, if we will first perform addition, like 4 plus 6, 10, and then multiplication. So, the answer will be 20, isn't it? But if we remember our high school mathematics, this is not the correct way to perform this expression, isn't it? So, what is the correct way? First, we will perform multiplication. So, first we will perform multiplication. So, 4 plus 12 and then addition, 16, isn't it? So, by remembering our high school mathematics, the problem is solved by operator precedence rule. And in arithmetic expression, we follow this precedence. Let me write here which operator has what precedence. Okay. So, order by operation. What is the order of operation? First, parenthesis. Highest precedence is given to parenthesis. Okay. Second, exponents. The symbol is like this. So, if I want to write 2 raised to 3, I write like this. Okay. Exponents. Third, multiplication and division. So, multiplication and division have equal precedence. Fourth, addition and subtraction. Again, addition and subtraction have equal precedence. Okay. So, by using operator precedence rule, we can solve this kind of expressions. Okay. Now, we'll take another expression like 2 into 6 divided by 2 minus 3 into 7. So, again we have taken this infix expression. Now, we'll evaluate this infix expression. Now, you can see that there are three types of operators: multiplication, division and subtraction. As we know, multiplication and division have equal precedence. Here we can see multiplication and division have equal precedence. Now, the question is whether to perform multiplication first or division. For this reason, there is one more rule, that is associativity rule. We know that multiplication and division have left to right associativity. Left to right associativity. Similarly, plus and minus have left to right associativity. Left to right associativity. So, by using this associativity rule, we can say that multiplication will be performed first. So, 2 into 6 is 12. Then 12 divided by 2 is 6. So, 6 minus 3 multiplied by 7. Now, again there are two operators, subtraction and multiplication. But multiplication has higher precedence. See, multiplication has higher precedence than subtraction. So, multiplication will be performed first. So, 6 minus 21 and then finally subtraction. Answer is minus 15. Isn't it? So, for solving these expressions, we require two types of rules. One is operator precedence rule and another is associativity rule. So many rules we have to follow in order to solve this expression, isn't it? Another way to solve this expression is that we can use parenthesis. So, we will use parenthesis like this, and with the help of this parenthesis also we can solve this kind of expression. But if we use parenthesis, then there will be memory wastage, and in fixed expression there is always problem of ambiguity, isn't it? Because there are a lot of things to be considered, like operator precedence rule, associativity rule, isn't it? There is a problem of ambiguity, and in order to resolve this problem, there are two more types of expression, that is postfix expression and prefix expression. In this expression, there is no need of parenthesis and no need to take care of operator precedence and associativity rules. Okay. So next is the prefix expression. So in prefix expression, operator comes before operand. First there will be operator and then operands. Okay, so we can write here as prefix expression equals to operator, then operand, and then again operand. So this is how a prefix expression is formed. And prefix expression is developed in 1924 by a Polish logician. And hence it is also called as Polish expression. Okay. And the examples of prefix expression are plus AB, first operator and then operands. The another example is plus 2, 3. Okay. So this is a prefix expression. The next is the postfix expression. So what is a postfix expression? Operator comes after operand. First there are operands and then afterwards there is operator. Okay. And it is also called as reverse Polish expression. Reverse Polish expression. This is Polish expression. And this is reverse Polish expression. And how a postfix expression is formed? Postfix expression equals to, first there will be operands and then there will be operator. Okay. Examples A, B plus, one more example 2, 3 plus. So this is a postfix expression. Okay. Now let us see how an infix expression is converted into prefix expression and postfix expression. For this, let us consider an example A plus B into C. So this is an infix expression. We'll convert it into prefix expression. Okay. So by using operator precedence tool, we know first multiplication will be performed. B and C multiplication will be performed first and then addition will be performed. Okay. So now converting into it prefix expression, first we'll perform multiplication, that is B into C. So we can write here as A plus multiply by BC. Because we are converting into a prefix expression and we know that in prefix expression first operator and then operands. So similarly first there is operator, multiplication and then operands. Okay. Now we will perform addition. Now addition will be performed between A and this entire prefix expression. So again we know operator will come first. So plus A then into B, C. So this is how an prefix expression will be formed. Okay. Now converting this infix expression into postfix. This is prefix. Now postfix. Now in postfix expression we know that first there will be operands and then operator. So B multiply by C. We can write here as A plus BC into. Okay. And now there will be addition between A and this entire postfix expression. So we'll write here as A, B, C into plus. So this is a postfix expression. Okay. And in postfix expression there is no need of parenthesis. So here we have removed parenthesis also. Okay. So this is generally I have shown you how infix expression are converted into prefix and postfix expression. Okay. And One more thing about postfix expression is that postfix expression are easiest to pass and least costly in terms of time and memory. Even prefix expression are least costly in terms of time and memory, but the algorithm of postfix expression is straightforward. Algorithm is straightforward, so easy to follow. And because of this reason, postfix expression is most widely used for computation. Okay. Also, prefix and postfix expression are good for machines and infix expression is good for human readability, and therefore there is a need of conversion of infix expression to prefix and postfix. So that's it for today. Hope you understood my today's lecture, and if so, then give this video a big thumbs up, subscribe to my channel and share it with your friends. In my next lecture, we will see in detail how infix expression is converted into postfix. Okay.